Now, the if a force is applied to move the body and it does not move, then the friction developed is called which friction?
Static.
Static friction, which is equal to what? It is equal to applied force, and it is in opposite direction to the applied force. Now, all of you, observe clearly, Nana. One surface is there, on that I kept object and I applied force in this direction, and frictional force developed in between this surface in this direction. And when it will not move? When these two forces are balanced. Suppose if these two forces become unbalanced, then what happens?
So the object will move.
Very good. Object will move. So, object will move. So, when object will move? Until it becomes unbalanced force. So, that means up to certain limit, what happens? The force we applied and frictional force will balance with each other. And to balance, what happens? This frictional force go on adjusting itself. That's why we are calling it as self-adjusting force. Okay.
Yes.
Okay. And in previous class, you learned that the frictional force is always proportional to normal reaction, which is R, isn't it?
Yes, sir.
Others, is it right or wrong? The frictional force between two surfaces will be proportional to normal reaction.
Yes, sir.
Naisha? Arya?
Yes, sir.
So, frictional force is proportional to normal reaction. Is it right or wrong?
It's right, sir.
Sir, that's right.
Okay. So, normal reaction I mentioned with what, Nana? R here. But here in this particular slide, so here it was given that N. N is also what? Sliding, sorry, normal reaction. What is normal reaction? Anybody tell me? What is normal reaction?
Sir, may I?
Let me give 1 minute of time. Naisha.
It's a force acting perpendicular to where the friction happens.
The force acting perpendicularly. By what? By what? Naisha.
To where the friction happens.
Hmm? Kavya? Kirtana? Normal reaction.
Is the opposing force acting perpendicular to an object? If
Opposing force. Is it opposing force?
perpendicular.
It is a perpendicular force. Perpendicular force by what? Which will apply on what?
From like the surface of to the object.
Not clear. Any other? Ronak?
May I?
Ah,
Yes, sir. So the outward force acting perpendicular to the surface of the body is known as normal reaction.
surface of the body. Okay, one object is there. So let me draw one diagram, and from the diagram you say, Nana, this is surface, this is particular object. Now tell me, here center of mass is there. Whether this will be normal reaction or this will be normal reaction.
So the upward arrow.
This upward arrow will be called normal reaction. So now tell me, this normal reaction was applied by surface or object?
The surface.
Very good. Surface will apply force on what?
The object.
Very good. You have to say like this. The force applied by surface on the object perpendicularly or normally will be called normal reaction. And that normal reaction generally will be equal to weight of that object. And maybe in previous class also we wrote R is equal to mg equation. Whether we wrote?
Yes, sir.
Okay. Now, here in this case, what we are doing is, see, I am writing here again. The frictional force which is acting between two surfaces when the object is in a state of rest, that will be called static frictional force, and this static frictional force will be proportional to normal reaction. Instead of writing R normal reaction, we are writing as what? N. So when we remove this proportionality, what we write? Just like in a previous class, I told you we have to write mu here, and that mu will be called coefficient of friction. But here I am writing mu s into n. That equation is only there here, isn't it? So Fs is equal to mu s into n, where this mu s will be called coefficient of static friction, n will be called normal reaction, Fs will be called static frictional force. Is it clear, all of you?
Yes, sir.
Others? Kavya,
Yes, sir.
is it clear? Fs
Yes.
is equal to mu s into n I wrote. Fs means what, Kavya?
Static frictional force.
Very good. What is n?
N is the normal reaction. Normal
Okay.
force.
Normal force or normal reaction also you can say. Next, what is mu s?
It is the coefficient of friction of the static friction.
Very good. You have to say directly like this. Mu s is nothing but coefficient of static friction. Okay.
Yes, sir.
Okay. Now, can anybody say what are the units of coefficient of static friction? What are the units of coefficient of static friction? Ronak?
Sir, no unit.
No unit. Good. Why no unit, Naisha?
Sir, may I? Sir, may
Next,
I?
Kirtana. 1 minute. Ronak, 1 minute. Kirtana,
Yes, sir.
tell me why no unit?
I'm not sure.
You are not sure. Others?
Sir, may I?
Ronak. Ah,
Yes, sir. Sir, because the sir unit of frictional static frictional force is Newton and normal reaction is also Newton. So in division Newton will get cancelled and coefficient the unit of coefficient of friction is nothing.
very good. In previous class, I told you people that if any physical quantity is a ratio of same physical quantities, definitely that particular physical quantity will not have any unit. So here, coefficient of static friction will not have any unit. Is it clear? Static friction? Now tell me, for a static friction, the object must be in a state of rest or motion.
State of rest.
Kavya? State of?
State of rest.
Very good. So state of rest. When an object is there in a state of rest over the other surface, then whatever the friction is there between those two objects or surfaces, that friction will be called static friction. Okay. Now let us move to next friction, which is called kinetic. Kinetic is also called dynamic friction. Okay.
Yes, sir.
Okay. Now if force is applied to move the body and it moves, then the friction developed is called which friction? Dynamic friction or kinetic friction. Now similar to that of static friction, kinetic friction Fk is also proportional to, sorry, let me write it down. Kinetic frictional force Fk is proportional to normal reaction. So Fk is proportional to N, and Fk, if you remove this proportionality, we have to write mu k into N. Why we have to write mu k? Because to understand it is a kinetic friction. And now tell me, what is this Fk, what is this mu k, what is N?
Sir, Fk is dynamic or kinetic friction. Uk
Okay,
is the coefficient of dynamic or kinetic friction, and N
okay,
is the normal reaction.
okay, very good. So the kinetic frictional force is always proportional to normal reaction. That means Fk is proportional to N. And if you remove proportionality, you have to write one constant, and that is mu k. And that mu k is called coefficient of kinetic friction or dynamic friction. And this coefficient of kinetic friction mu k is equal to what equation you can write? Fk by N. So this is kinetic friction and this is normal reaction. And kinetic friction will have a unit of Newton. This normal reaction also will have a unit of Newton. These two will be cancelled. That's why mu k also will not have any unit. Just similar to that of static friction. It is easy to understand. Static friction means when object is there at a state of rest. If an object is moving on that particular surface, then the friction, whatever is there, is known as what?
Kinetic friction or dynamic friction.
Very good. Now, if I ask anyone which friction is less, which friction is less, whether kinetic friction is less or static friction is less.
Sir, kinetic.
Kavya.
I think it is static friction.
Next, Naisha.
Kinetic.
Next, Arya.
Sir,
Tell me, Arya, whether kinetic friction is more less or static friction is less.
sir, kinetic is less.
Okay. Now, if I ask all the people, tell me what is your answer. Suppose object is there in a state of rest, it is a big block and I applied force, still it is not moving, and when I increase force, after that it started moving, and after starting the motion, is it easy to increase its velocity or not?
Yes, sir.
So it is easy to increase its velocity after it starts moving, but before that it is bit difficult to make it to move when it is there in a state of rest. So that means static frictional force will be more than that of a kinetic friction, isn't it?
Yes, sir.
that you can understand by this graph, and on your screen one graph is there. Observe carefully, all of you. Now on x-axis what we took is pulling force. That means whatever the force you applied externally, that force we took on x-axis, and frictional force which is acting in between two surfaces, that we took on y-axis. Observe carefully this particular graph. Sorry, here this is frictional force, and this is, sorry, this is pulling force here. X-axis pulling force, y-axis frictional force. And if you observe the graph here, state of rest is there. For state of rest, if you go on increasing the force, frictional force also will increase, and it will increase up to a maximum value, and this maximum value here also will be known as what? Anybody tell me?
Limiting friction.
Very good. It is called limiting friction. Sorry. Limiting friction. And after limiting friction, whatever is there, that will be called kinetic friction or dynamic friction. And that dynamic friction will be less than that of this static friction. That's why if you observe the graph, in a state of rest, it is like a straight line, and after that it will bend, and after that for a kinetic whatever friction will be there, that will be a constant after certain extent, after decreasing up to certain level. So this is about graph, and from this graph you can understand that the kinetic friction is less than that of a static friction, isn't it?
Yes, sir.
Okay. Now, generally, why this type of static or kinetic friction will produce? Because static or kinetic friction will produce by the deformation. What Nana? Deformation. Deformation means what? Change in shape of it. And to understand this deformation, now let us take a tire. Rubber tire is there and it is moving on the surface like this, and when it is moving on the surface, you observe here wherever contact is there, what do you observe there? What do you observe there?
Sir, it is pressed and it goes down.
It will press there. When it is pressing, observe carefully the tire shape look like changed. Have you observed?
Yes, sir. It looks like oval shape.
Tell me others. Have you observed it? Whenever the tire is touching that surface, it look like its shape is changed. Have you observed, Arya?
Yes, sir.
Try to observe again. Okay. Kavya,
Okay.
Yes, sir, you have.
have you observed at any time the tire look like bended or that shape is changing somewhat when it
It's a
is touching the
punctured,
surface? Huh?
when it's a
Sir,
punctured tire.
Kavya,
When it's a punctured tire.
when tire is touching the surface, you can see it, some deformation. That means some change will be there in the shape of that tire. And due to that deformation, or else area of contact, whatever is there, on that, what will depend? This frictional force will depend. If area of contact is less, frictional force will be less. If area of contact is more, frictional force will be more. Now let us learn about kinetic friction. And to understand about kinetic friction,